Hello everyone, welcome to my class again. Today we are going to learn about numerical, descriptive, statistics. So there are three things we are going to learn in this chapter. We are going to learn about central tendency, dispersion, and skewness. However, I have separated the chapter. So today we are going to focus on central tendency and quartile only. Okay, so part 1, introduction. So in descriptive statistics, our main concern is to organize, summarize, and present the data. When we want to present data, we need to understand the data. So first, we need to know the central tendency, the middle point of the data, the average of the data. Okay, because often the average or the middle point represent the data. And then we also want to study the dispersion. The dispersion actually means the size of how far apart the data is with each other. Okay. And then skewness refer to the biasness or the unbiasedness of the data. Sometimes a data can be so skewed to one side that it's not representative of the data or the value of the data or the population of the data. Okay. So measure of central tendency. Central tendency refers to the middle point of the data. The purpose we want to find central tendency is because we want to summarize the information by means of a single number, which will serve as a representative of the data. So we have three measurements. We have mean, median, and mode. We are going to learn about the mean first. So mean is actually the average value of the data. In this chapter, we are going to calculate mean for raw data, mean for ungrouped frequency distribution data, for group frequency distribution data. Okay. So mean for raw data. Okay, let's say the mean of a set of raw data is obtained by adding together all the items and dividing by the total number of the items. Let's see. The formula for mean of raw data is as such. So mean equal to summation of Fi, in which I is the number 1, 2, 3 up till n. N is the total number of frequency or the total number of items. So let's see example 2.01. Suppose John gains the following mark in his school examination. So there are 5 subjects. So the first one he gets 48, the second one he gets 64, and third is 55, and then 54 and 74. So this 5 data is his mark. And we want to find the mean mark for John. Solution, mean equals to the summation of these 5 data divided by the number of the data. So in this case, 48 plus 64 plus 55 plus 64 plus 74 divided by 5 because there are 5 marks. And then we will get the mean is 61. This is how we calculate mean for raw data. Okay, mean for ungrouped frequency distribution. For ungrouped frequency distribution, the formula is summation of Fi and divided by summation of Fi. In this case, Fi refers to the frequency. Okay, let's see example 2.02. Okay, we have the following data represent the score obtained when a dice was tossed 60 times. Find the mean. So a dice have 6 faces. So when we toss it 60 times, the number we get, so we get 1 8 times, we get the number 2 9 times, we get the number 3 12 times, we get 4 13 times, we get 5 12 times, we get 6 6 times. That's what's meant by the data. Now we want to find the mean. Solution. Okay, first let's create a column or a row for Fi. So how can we calculate Fi? So Fi is basically frequency times the data. So in this case, 8 multiplied by 1, you get 8. 19 multiplied by 2, you get 18. 12 multiplied by 3, you get 36. 13, you multiply by 4, you get 52. 12 multiplied by 5, you get 60. 6 multiplied by 6, you get 36. Okay, that's how you get FISI. But this is not the mean yet. Okay, to calculate the mean, you have to sum all the FISI. So 8 plus 18 plus 36 plus 52 plus 60 plus 36 divided by the summation of the frequency. So divided by 8 plus 9 plus 12 plus 13 plus 12 plus 6. So you get the mean equal to 3.5. So that is how you calculate mean of ungrouped frequency distribution. Okay, so now let's see mean for group frequency distribution. For group frequency distribution, the formula for mean is mean equal to summation of FIXI divided by summation of FI. In this case, FI is still our frequency. However, our XI is the midpoint. So let's say example. Let's say we have this data. We have 5 class intervals. Find the mean. Okay, so since this is group frequency distribution, okay, so we have the original class interval, Fi, and so we have to find the midpoint. So how to find midpoint? You have to remember midpoint is equals to the upper limit plus the lower limit divided by 2. So 20 plus 1 divided by 2. So 21 divided by 2, you get 10.5. So that's how you calculate your midpoint. Do the same thing for the rest of the class. And then you calculate FIXI. So FIXI, frequency multiplied by midpoint. So our frequency is 9, our midpoint is 10.5, so we will get 94.5. So then you repeat this for the rest of the class, and then you total up, so you get summation of FIXI is 1945, and then you total up the frequency, you will get the summation FI equal to 50. So mean equals to 1945 divided by 50. So mean equals to 38.9. So that's how we find mean of group frequency distribution. Now let's go to the median. Median is the middle number when the data is arranged in order of size. Often, we will rearrange the data in ascending order. It's very rare, almost never, for us to arrange the data in descending order. Okay, so let's see. Median for raw data. Given n measurement arranged in order of magnitude, we have median equals to, in bracket, n plus 1 divided by 2. This one shows the position of the items. Okay, this is not your median yet. This is just the position of the items to calculate which position is the median. However, there are other ways for you to calculate the median. The next one is median equals to middle value if the n is odd number. Median is also equivalent to mean of the two middle value if n is even number. Okay, let's see. Example 2.04. Find the median for the following data. In this case, n is odd. So we have 45, 48, 55, 64, 64, and 74. So we have 5 data. 5 is an odd number. Solution. Okay, so since the data is already in proper arrangement, so we don't have to rearrange. So median equals to 5 plus 1 divided by 2. So 5 plus 1 is 6. 6 divided by 2, you get 3. But 3 is not the median yet. 3 is the position. So 3. So the position 3 is referring to this 64. So 64 is actually the median. So the median equals to 64. Now let's continue. So you have example 2.05. So in this case, the n is even. Find the median of the following data in which n is even. So you have 2, 4, 6, 1, 2, 3, 3, 2. So this data is not in proper arrangement. So you have to rearrange the data. Solution. First, rearrange the data in ascending order. So you arrange it properly. So you get 1, 2, 2, 2, 3, 3, 4, 6. Then you calculate the median position. Okay. To find the position, 8 is the total n. 8 plus 1 divided by 2. So 9 over 2 is 4.5. So 4.5. So 4 and 5. So between 4 and 5. So the fourth value is 2. The fifth value is 3. So 2 plus 3. 2 plus 3 divided by 2, you get 2.5. So 2.5 is actually the median. Okay. For even number, you have to do this extra step. Okay, so now let's see median of ungrouped frequency distribution. Okay, the formula is basically just like before. However, you are going to determine the class using the cumulative frequency distribution table. Example 2.06. Given the following data, determine the median. So we have data of score. So score 3, 4, 5, 6, 7, 8, and then the frequency for each score. So because this is a frequency distribution, so we need a cumulative frequency column or row. So calculate the cumulative frequency. How to get the cumulative frequency? For the first class, we assume 16 plus 0, you get 16. And then 16 plus 24, you get 40. 40 plus 27, you get 67. 67 plus 29, you get 96. 96 plus 16, you get 112. 112 plus 3, you get 115. So the total N is 115. So median equals to, this is the position first, okay? The position first. So 115 plus 1 divided by 2. So 116 divided by 2, you get 58. So where is 58? So you look at the cumulative frequency. So 58. Okay, the first class is up until 16. The second class is up until 40. 58 is bigger than these two class. So not in these two class. Okay, the third class is up until 67. So 58 is actually less than 67. So 58 is actually in this class. Okay, so this class is actually the score 5. So median is actually equal to 5. You don't have to write the formula again. You can just simply write median equal to 5. So that is ungrouped frequency distribution. Now let's see group frequency distribution. Okay, for group frequency distribution, we are going to use linear interpolation method. So this is our median formulas. Median equal to L plus Cm divided by Fm in bracket n over 2 minus summation of Fm minus 1. So what is L? L is the lower class boundary. And then Cm is the size of the median class. Fm is the frequency of the median class. Summation of Fm minus 1 is actually the cumulative frequency before the median class. And then n is the total frequency. Let's see the example for us to understand. So example 2.07. Find the median of the following data. So this is our data. We have 5 intervals and the frequency. Solution. Okay, solution. You have to find the cumulative frequency first. So 9 plus 0, 9. 9 plus 17, 26. 26 plus 19, 45. 45 plus 4, 49. 49 plus 1 is 50. And then after you find the cumulative frequency, the next step is to determine the median class. Okay, so where is the median class? Okay, median class equals to 50 divided by 2, so 25. So 25 is actually in this class, okay, because the cumulative frequency, see, 25 is bigger than 9, so obviously it's not in this class, but then it is lesser than 26, so obviously it is in this class. So this is our median class. Our median class is referring to 21 till 40. So step 3, after you get the median class, then you can actually calculate the median. So median equals to L, okay, this is the formula. So in this case, our L is 20.5. Why? Because this is our median class. So the lower boundary for this median class is actually 20.5. How do you know the L is 20.5? 20 here plus 21 divided by 2, you get 20.5. The 20.5 is at the lower boundary. And then plus by the class size. Okay, class size. How to calculate class size without calculating the class boundary? Here, 21 minus 1. So 21 minus 1 is 20. So that is the class size, 20. Or you can also calculate it manually. Okay, and then divided by the frequency of the median class. So median class is here. And then the frequency, okay, not the cumulative frequency. The frequency is 17. So 20 divided by 17 times n is 50 divided by 2 minus 9. 9 is the cumulative frequency of the class before the median class. So median class is here, class before is here. So the cumulative frequency of this one, so 9. So 50 divided by 2 minus 9. And then you get median 39.32. Now let's go to mode. Mode is the number which occurs most frequently. Some data may not even have mode. Some have one mode, some have multiple modes. Okay, mode of raw data. Let's see example. Find the mode of the following set of numbers. So we have A, example A. We have 1, 1, 4, 4, 5, 6, 8, 8, 8, 9. Okay, so let's see all the examples first. Okay, so we have 4 examples. And now let's see the solution for each one. A, so A here. So let's go through here. 1, 1, 4, 4, 5, 6, 8, 8, 8, 9. So 1 happened twice, 4 happened twice, 5 happened once, 6 also happened once, 8 happened 3 times, 9 happened once. So 8 is the mode because it occurred the most. So it occurs 3 times. So mode equals to A. So for B, let's go through B. 48, 55, 64, 64, 74. So 48 is once, 55 is once, 64 is twice, 74 is once. So 64 is the mode because 64 happened twice. And then you have C. Okay, let's go through C. 22, 26, 90, 23, 85. No repetition whatsoever. Each element happened only once. So no mode. Okay, now let's go through D. So D, we have 20, 20, 21, 21, 21, 48, 48, 49, 49, 49. So 20 happened twice, 21 happened 3 times, 48 happened twice, 49 happened 3 times also. So for this data, this set of numbers has 2 modes, 21 and 45, because both happened 3 times. This data is said to be multi-mode because it has more than one mode. Now, how to find mode for ungrouped frequency distribution? Example 2.09. Find the mode of the following frequency distribution table. So we have the example. So height of student, number of students. So 3 students have height of 155, 7 is 156, 10 is 157, 15 is 158, 16 is 159, 9 is 160 cm, 2 students is 161 cm tall. So solution. So for mode, what we are going to do is we are going to look at the frequency, or in this case number of students, and we are going to look at each one of them, and we are going to select the highest value. So in this case, the highest value is 16. So 60 refer to 159. So mode equals to 159 because 16 students have 159. No one has this the number of students who is 159 cm tall is the most student is 159 cm tall in this class. Okay, so now we are going to see mode for group frequency distribution. So in group frequency distribution, we have something called model class. Model class is the class which has the largest standard frequency. An estimate of the mode can be obtained from the model class. Okay, so there are two methods. First, you use the histogram. So you draw the histogram and then you look at the rectangle bar, and then the one with the highest rectangle bar is the model class. Okay. And then method 2, using a formula. So this is our formula. Mode equals to L plus, in bracket, A divided by A plus B multiplied by C. So what is L? L is the lower class boundary of the model class. What is A? A is the difference between frequency of the model class and the frequency of the previous class. B is the differences between the frequency of the model class and the frequency of the next class. And C is the size of the model class. Okay, let's see example so we can see better. Okay, find the mode for the following data. So you have the class interval, 5 class interval, and then you have the frequency. So solution. So you find the class boundary for each class first. And then you know how to find the class boundary. So the class boundary basically is just 20 plus 21 divided by 2. You get the upper class boundary, which is 20.5. Okay. For the lower class boundary, it's also the same here. 20 plus 21 divided by 2, you get here. Okay. That's how you calculate class boundary. Okay. So mode. Okay. So frequency. Let's look at the frequency. So here we have the highest frequency here. Okay, which refer to 41 till 60. Okay, so obviously this is our model class. Okay, remember this is our model class. So this is our formula. So L is actually the lower boundary for the model class. So our model class is here. Lower boundary is here. So 40.5 plus. Okay, A. A is the differences of frequency of the model class with the frequency of the next class, in the previous class, sorry. So 19 minus 17. So 2. 19 minus 70. A equal to 2 divided by A plus B. So just like before, 19 minus 17. So this 2, this A. And then B is the difference between frequency for model class and the next class. So 19 minus 4. So 19 minus 4 is 50. So basically 40.5 5 plus 2 divided by 2 plus 15 multiplied by 20. 20 C. C is the class size. How to calculate class size? Okay, in this case, you can calculate the class size by 20.5 minus 0.5 or 21 minus 1. So you get 20. Okay, you can also calculate the class size this way. 40.5 minus 20.5, you get 20. There are multiple ways for you to calculate class boundaries. Okay. So the mode after you calculate is actually 42.85. So that is our measure of central tendency. However, sometimes the measure of central tendency only are not enough to reveal the whole picture of the distribution of the data set. Measure of central tendency does not describe how the data is distributed. Let's say example 1.11. Actually, it's 2.11. Okay. So data set, we have data set A and B. So data, this is our data. So if you look at the mean, median, and mode, both set have the same mean and the same median has the same mode. But if you look at the data, both set data is different. So for here, the set A, you see 1 is the smallest and then the highest is 26. And then if you were to draw a normal distribution table, normal distribution graph, the bell-shaped graph, you will see that the graph is wider because it covers 1 to 26. However, if you look at the dataset B, the smallest is 7 and the highest is 17. So if you draw the bell-shaped graph, you will see that the graph is not as wide as the set A, okay, because it has smaller range. Okay, range is when you calculate the difference between the highest and the lowest. So range is 26 minus 1. So range for A is 25. 26 minus 1, 25. Okay, so dataset A has lower range, it has higher range than B. So because dataset A has 26 minus 1, so 25 range, and dataset B is 17 minus 7, so only 10. So the range in B is lower than the range in A. So the dataset A is wider and the dataset B is narrower if you draw the bell-shaped graph. Okay, so for measure of dispersion, there are two ways to measure dispersion. First is through quartile, and then the second one is variance and standard deviation. But today we are only going to focus on quartile. Okay, so for quartile. Okay, quartile are three measures that divide a ranked data set into 4 equal parts. So you have the data, and then you have the Q1, the Q2, and the Q3. So Q2 is basically the median. The second quartile is the median. And then the quartile one is actually the lower limit, the lower portion of the data. And then the quartile 3 is the upper limit or the upper portion of the data. There are three measures of quartile: first quartile, second quartile, and third quartile. So let's see how to measure quartile for raw data. Consider M item arranged in ascending order. Then the formula will be as follows. First quartile, Q1, the lower quartile, equals to 1 over 4 in bracket and plus 1. The second quartile, median, the Q2, equivalent to 1 over 2 in bracket and plus 1. And then the third quartile, the upper quartile, our Q3, equals to 3 over 4 multiplied by in bracket and plus 1. And then the interquartile range is Q3 minus Q1. So the interquartile range is basically the difference between the upper portion and the lower portion. And the number of data in between the lower and the upper portion. Okay? So continue. Let's say example 2.12. Find the lower quartile, upper quartile, and interquartile range for the raw data. So you have 20, 28, 40, 12, 30, 15, and 50. So you have to rearrange the data in ascending order first. So it will become 12, 15, 20, 28, 30, 40, and 50. And then you calculate the Q1. So Q1 is 1 over 4 multiplied by 7 plus 1. So you get 2. So 2 is not the first quartile. 2 is the position. So 2, look at the data. The number in position 2 is 15. So quartile 1 is 15. So for quartile 3. So for quartile 3, we have 3 over 4 multiplied by n plus 1. So in this case, n is 7. So 7 plus 1, so 8. So 3 over 4 multiplied by 8 equals to 6. So 6 is the position. So quartile 3 is in the 6th position of the data. So the 6th position is this one. So 6 is 4. So 6th position, so 40. So quartile 3 is 40. And now the interquartile range is 40 minus 15 because Q3 minus Q1. So equivalent to 25. Now quartile of ungrouped frequency distribution. Example 2.13. Given the following data, determine the first quartile, third quartile, and interquartile range. So we have this data. We have score 3 to 8. We have the frequency for each class. The solution. So we have to, because this is ungrouped frequency distribution, we have to find the cumulative frequency. So Q1 equals to 1 over 4 multiplied by 115. 115 is n here. 115 is n plus 1. So you get 29. So 29 is the position of the quarter 1. So 29, where is 29? So 29 is here because 29 is bigger than 16 and 29 is lower than 40. So 29 is in this class. So this class refers to score 4. So quartile 1 is 4. Quartile 3 equals to 3 over 4 times 116 equals to 87. So 87, where is 87? 87 is here because 87 is obviously bigger than 67, but 87 is lesser than 96. So 87 falls in this class. So this class refers to 6, the scores of 6. So quartile 3 equals to 6. The interquartile range is 6 minus 4. So the interquartile range is 2. So quartile for group frequency data distribution. Method 1, estimate using OGIE. The second method is using linear interpolation. So for linear interpolation, this is the formula. So this is quartile 1. So we have the lower boundary of quartile 1 class plus the size class of quartile 1 divided by frequency of quartile 1 in bracket n over 4 because quartile 1 refers to the first quarter of the data. So 1 over 4 minus summation of fq1 minus 1. So cumulative frequency of the class before the quartile class. The same thing goes for quartile 3. The difference is here 3 over 4 instead of 1 over 4 because quartile 3 represents the upper portion of the data, the 75% of the data, the third quarter of the data. So the difference is here 3 over 4 instead of 1 over 4. The rest is basically the same. So let's see. Okay. L is the lower class boundary, and then C is the size of class, and then FQ is the frequency of the quarter class, and summation of FQ minus 1 is the cumulative frequency before the quartile class. N is of course the total frequency. So continue. Let's see example 2.14. So, given a set of data in the following table, find the first quartile, third quartile, and interquartile range of the following data. So here we have the same data as we have used before. So we have 5 class intervals, sorry. So the frequency. Now let's see how to solve this problem. Solution. So you must first find the cumulative frequency. So step 1, you determine the Q1 and Q3. So Q1 is 1 over 4. So n plus 1 divided by 4. So 50 plus 1 divided by 4, you get 51 divided by 4, you get 12.75. And then you get, okay, so the quartile 1 class is here, 21 till 40, because 12.75 is bigger than 9 but lesser than 26. So quartile 1 lies here in this class 21 till 40. So for quartile 3, so we want to find quartile 3 class. So 3 times 51 divided by 4. So you get 38.25. So 38.25 is here. So Q3 class is here at 41 till 60 class. And then you calculate the Q1 and Q3 using the formula. So that is the formula for Q1. So 20.5 is the lower boundary for Q1. So Q1 is here. So the lower boundary is 20.5 plus the class size is 20 divided by the frequency of the Q1 class. So Q1 class is 70 here. In bracket 50, the n divided by 4 minus 9. 9 is the cumulative before the Q1 class. So the cumulative frequency before Q1 class is here, 9. So you get 24.62. And then you get Q3. So Q3 is, and this Q3 is 41 to 60. So the lower boundary is 40.5 plus class size is 20 divided by 19. 19 is the frequency for the Q3 class. And then 3/4 times 50. 50 is n. So minus 26. So because our Q3 class is here, the cumulative frequency before them is 26. So that's why we minus 26. And then it will equal to 52.61. So our Q3 is 52.61. Our Q1 is 24.62. Into quartile range, you get 27.99. Q3 minus Q1. So the other way to estimate quartile is to use OGIE. So given the following data, estimate the 3 quartile using an OGIE. So this is our data. Remember, if you want to draw an OGIE, you will have to find the upper boundary because OGIE for group data are drawn against upper boundaries. So this is our OGIE. So make sure first you have to draw the OGIE. So this is the OGIE. So this is the OGIE. And then, since our total frequency is 50 and we understand that Q1 refer to the 1/4 of the data. So 1/4 times 50. So basically 50 divided by 4, you get 12.5. So here, you mark at 12.5. Make sure it's 12.5. 12.5, you draw a straight line until it hit the OGIE. And then you go down. And here is actually your quartile 1. Okay, the estimation value for quartile 1. And then for quartile 3 is also the same. So quartile 3 is 3/4 times n. So 3 times 50 divided by 4, you get 37.5. So make sure here is 37.5. And then you draw a straight line until it hit the OGIE. And then you go down. You go down until it hit the x-axis. Here, the value here, where it intersects with the x-axis is your quartile 3, the estimation value of your quartile 3. The same if you want to find the median, okay, the median or the quartile 2. So median is basically half. So half of 50 is 25. So 25, so you basically draw 25 until you hit the OGIE and then go down, see the x-axis, and then identify the number here. So whatever the number here is the median, okay? So that is how you estimate quartile using OGIE. So that is the end of part 1 for chapter 2. So we will continue next week with variance, standard deviation, skewness of the graph of the distribution. Okay? Thank you.